Okay, now we have the fourth property that we need to learn about, and that again, it deals with something inside the parallelogram. Now we've already talked about the angles, but now we're going to talk about the diagonals. Now, the diagonals have a special property when it comes to parallelograms. First, I'm going to draw the diagonals for the parallelogram. So, let me come over here, and I'm just going to draw this like that, and draw this like that. Sorry for the curvy line there. Okay? All right? There are your diagonals. Now, they're going to meet, of course, at a point, and we're going to call that point, we'll just call it M. Okay? That's just a letter that we're going to use. So we're going to call that point M. But here's the beauty of this, though. Here's the beauty of this parallelogram and the property of it. When these diagonals are drawn, something happens. And what happens is that it actually bisects the diagonal. And what I mean by that is that if you go from P to R, which is a diagonal, and M is right here, this happens to be the midpoint of PR. Okay, so I can make a mark on both of those. Okay? Now, since M is a midpoint of PR, it also kind of says that M is a midpoint of QS. So I can bisect, so that's going to show a bisector as well. Okay? So, here's what you have to remember. What you have to remember is that the diagonals of a parallelogram bisect each other. Okay? Okay, that's what you have to remember. Okay, so that's a special property, another special property of parallelograms, that those diagonals indeed bisect each other. So in this problem, what that means is that PM, the line segment PM, is congruent to MR. And QM is congruent to MS. Mr. Miss. Anyway, that's what's happening here on this problem. So the diagonals bisect each other, and that's what's happening here. Now we're going to do two example problems, one on a coordinate graph, coordinate grid, and then we're going to come back here on this, and that will take care of our lesson for today. All right? So let's follow me. Notice here that I have parallelogram VWXY. Okay? Now, what we want to do is we want to find where the diagonals meet at. Okay? So we actually want to draw we're going to actually draw the diagonals in and find out exactly where they meet. Okay? Now, the good thing about having it in a coordinate grid is that if you've drawn the picture correctly, it's going to be pretty simple to see where those diagonals meet at. Okay, so let's try to do that. Okay, I'm going to draw this diagonal like that. Okay, and then I'm going to draw this diagonal like that. Okay, now hopefully I've done it straight. I may not have. I might have kind of messed up on this one. So let me redo this. It's not a problem. So I'm gonna draw this straight. Yeah, that's a lot better. That's kind of where I want it to be. Okay. Now, again, it's very simple to see where the point lies, where the point is, where the intersection is of those diagonals, and it's gonna be right here. Okay. And we're going to call that point, in this case, Z. All right, point Z. All right. So, using simple lesson of plotting points, can you tell me where Z is? Let's count it out. Okay, this is the origin, right? So that's 1, 2, 3. It doesn't get to 4. It gets kind of halfway. So we'll say 3.5. And then we're going to go up 1, 2, 3. So Z, right, let's write it here. Z is at 3.5, comma 3. But I told y'all before that in high school it's okay to have improper fractions. So we're gonna make 3.5 a fraction. Anybody remember what that is as a fraction? That's right. Z is at 7 over 2, comma 3. So that is the point where the lines, the diagonals actually, intersect. Okay? Now, we have one more example that we're going to do. It has nothing to do with the coordinate grid. We're going to come back over here and talk about that problem. Okay? So let's follow me. Okay? Now, what I'm going to do is